Fine, sir. We will start it now. Good morning, everyone present here. First of all, happy Kannada Rajyotsava to you, everyone. So now coming to PyCamp SE. Hope you are all excited and enjoying our previous scheduled content. Now we have at last come to our most expected session, getting started with Python, and we have our beloved speaker Deepak Sharma with us. So let me give a small introduction about him, and we will give he will take over the session. Everyone can see my screen, I hope, sir. Okay. So about speaker, he's a Python developer from day one. So you can have a more confidence that yes, whether we have to learn other language like C, C++ or not. Like yes, even Python developers from day one can be also possible. He's an inspiration for us. And next, software engineer at Red Hat India. So if you are a Linux lover and you are developing your projects and everything in Red Hat Linux, then you will be knowing that what is the value of Red Hat in global wise. So he's the software engineer at Red Hat, and sir is 4+ years of developing experience. So he's almost like 4 years of senior to us. So we can make it like ask many conversation. We will get many rated things to discuss each other. And yes, worked with many various startups to big corporates. If you can visit their LinkedIn profile and get to know about like which all technologies they have worked on and which all corporates they have worked on and startups. So yes, sir, we are very glad to invite you to our first guest speaker session. So you are the first speaker to our Girls Shift SE. We are very thankful for you for making time and coming to our making some giving such opportunity for our students. Over to you, sir.
Okay, thank you very much for this warm introduction. So, yeah, hopefully everyone is doing fine in this pandemic situation. Yeah. So I will actually encourage you if the session will be a more communicative. So the communications will be a two-way around. So rather than I'm speaking and at the end you are just getting away with something very little, right? So let's make it a communicative session. Maybe I would learn something new from you guys that are quite much of possibility and other way around. Okay, so I encourage you all to switch on your cameras, and whenever you ask any question, just then switch on your microphone and let's begin. So, yeah, hopefully everyone can see my screen, right?
No, sir, we
Yes,
can't
sir.
see your
Yes, sir.
screen.
Okay.
Yeah, okay, sir. Yes, sir. Now we can see. Yes.
Management subject, but that
Yes, sir.
what analysis
Yeah, you can see, right?
Yes, sir.
in the
Now it's visible.
society.
Yes, sir.
Okay, cool. So this is the about me section. You can see. Let me confirm first. Okay. Hello. I would like someone to confirm the about me section is visible.
Yes,
Yes,
sir.
sir.
Yes, sir.
It's
It's
visible.
visible,
Yes, sir.
sir.
Yeah, sir.
Yes,
Oh,
sir.
okay, cool. Okay, cool. So I will firstly introduce myself. I am a software engineer. I blog and I am also a mentor. So I am in the corporate jungle for around 4 years, 4+ years. So I love in Python, and I also deal with the Kubernetes, containers, and tech talks. So blogging is one of my another passion. I blog, and so I love to travel. I won gold in the chess, and in this I think sports meet going on. So and along with side, I love football. I don't like is exiting Vim, of course. Yeah. So the Vim exiting Vim is one of my biggest. Uh, I fear about exiting and Python versus blah blah. Why and another thing I really don't like is the why Python is slow. People usually ask why Python is slow, but anyhow we will cover why Python is slow. But yeah, I will want you to stick with me. So moving on, what we will cover in this session is why Python, why not Python, and what environment setups you will likely to have, and some basics about Python. We will cover about why class and functional programming paradigms. Two types of paradigms we have in the Python. So what is the inheritance in Python and the difference between module, packages, library, framework, and why we need a framework. Okay. And later on, I'm planning to have give you guys some introduction to Django, some API design patterns. REST in Django, that means it's API design framework in Django. And we will design at the end a simple app in Django. So if in the end, if the time allows, we will containerize our application, and I will tell you how the production setup for a app, simple Python deployment works, and I will tell you how they containerize your application. We will introduce to Docker, what is the registry, and how you can push your image to registry. Okay. So hope everyone is clear about what we will gonna cover. So for first most, I would like you to see this snippet of code. And now I want any one of you to unmute yourself and give me what is the possible errors in this snippet. Maybe it's architectural design errors and code errors, whatever possible it is, just unmute yourself and tell me. So it is actually for primarily someone who are maybe some introduced to code. Maybe I think the C++ is very much you guys are familiar with. So on the same ground, I designed this snippet. So I expect someone of
Sir,
you
is
at
it
least.
the semicolon or the colon at
No,
the
no,
end
no,
of
no, no. Let me tell you, the Python is not all anything about colons, semicolons. Everything in Python and C++. C++ deals very much about colons, semicolons. And Python we don't have. We have indentations only to take care, and which I can confirm indentation, semicolon is not a problem in this snippet. So anyone else? Yeah, please come up.
Sir, in last print statement, the bracket
Mhm.
is
Printf,
same.
sir.
Okay, another thing I can confirm is the snippet. The syntax is not a problem at all. The syntax is again very much fine. I want some architectural kind of problems. Okay, so I can give you 30 seconds more. If anyone can come up, it will be great. Okay, so I think
So in the written
not
statement,
any. Yeah, sorry.
in the written statement company dot get, it should be the function name is different now, sir.
No, no, that's again not a problem. Okay, I will tell you. So the thing is, I will actually, we will start with what we really cover in the production type of environment. In that context, what currently this snippet has a problem is, it actually maintains the state. Okay, so now I will firstly cover what this snippet actually does. Client asks you to build a program, and if he or she enters a particular keyword, he will get the company of that scooter. Okay, so if you can see, we are taking the input enter scooter. So we are expecting someone to give the input. So let's suppose someone enters the let's say Bajaj, or let's say Activa. Someone enters Activa. So as soon as the client hits enter, your console will print out Activa is manufactured by and then it will look into the our dictionary in the top. So Activa is manufactured by Bajaj. So the in the current situation, we have two problems here. First, we can't ship that code to the client. Why? Because in the each scenario, we expect client to have the Python inbuilt in their server to run this particular snippet, which is not the very much case every time. And the second problem is we are maintaining the state. With the state, I mean to say we are maintaining kind of database in the particular application. So let's say the in the tomorrow another company came up with another scooter. The your client have to actually dive into your code to update the scooters, to update this database. So which is not the ideal scenario. Okay, so this brings up to your our first point, which we will cover. All your applications which you will design in the future or anything should be a stateless, which means it should not maintain a state, and the uh, responsibility to maintaining state should be outsourced to some particular external database. Okay, you should always try to make your client as dumb as possible. And by the word dumb, I mean it should not know anything or anything about the state or like that. Yeah. Okay. So hope everyone is clear. So let's jump over to next. Now, why Python? So it is very much easy to learn. Yeah, we have a large community support in Python, and it is very much stable. We have an extensive list of libraries available, be it is a standard library or external library, whatever. It is a mature. It is a language of choice for scripting, AI, ML, web development, everything. We have a good containerization support. Again, containerization topic I will cover later on. We have versatility, efficiency, reliability, and again speed. And we have a the Python is very much flexible. Okay, so here I would like say that large community support. You mean to say, let's say in tomorrow or a day after tomorrow, when you are writing code, you are stuck in something between some erroneous programs, or you are getting some errors or something like that. So here the language of your choice comes plays a very much important factor. Okay, so suppose you chose a language in your coding that is not used by a large of the community, and then you search Google that what is the this error means, you will hardly get any answer. So here if you choose a Python, for instance, if we choose the a simple search query in the Google will point you to the list of answers which you can solve and go ahead with your problem. So again, stability matters. You should not be dealing with language that is crashing at every point. The libraries, these are the external snippets which the third party writes, and you just use them in your import them into your current code and go on. So again, you need a mature language, which is again plus. So language of scripting, whenever you talk about scripts and AI, ML, and web development, so the first thing that comes into the mind is the Python again. Containerization support is again a good in Python. So that's all. So any question up to this point, I welcome you. No? Okay, let's go ahead. Why not Python? So here I would like you to assume that now the Sachin Tendulkar is not necessarily be good in chess, right? He sh- uh, he may not play as good tennis as he plays cricket. Okay, so same is the case with the Python. So Python can't be used in the front end language. So if you can imagine, you can replace the JavaScript or any other programming and then use Python in place of that JavaScript. You can't do that. Python is not meant to be used in the front end. So it is so similar is the case if you think about you can develop any mobile apps using Python. That again can't be possible. Android is the application language that is made for building Android apps. You can't replace Android apps with Python. So again, this is the memory intensive thing, by which I mean here we will cover this memory intensive later on. And again, it is a prone to runtime errors. So the another problem we have in Python is the database layer, which is currently underdeveloped. So the progress is made in this direction. So some guys again complain that Python is slow. We will this memory intensive and slow point, we will cover this again later in as we go along. So you are actually, if you have any questions, just unmute yourself and ask right away and let me know. Okay, else I am just going on, and I assume that everyone understood up to this point. So okay, so the typical development environment, how it looks like. So we as a developer typically develop in a Linux. We have a Mac. Yeah, somebody has a question. Okay, cool. So Python 3.6 is the de facto environment. We go ahead. So IDE, integrated development
Hello, sir.
environment, in which you code. Yeah, yeah.
Sir, Java or C++, which is very trending.
Yeah, I actually recommend you don't go after trending. Just go after what you want to, what your application is. So if your application is uh, develop, your client wants, or any third party which you want to develop a software, a desktop software. Okay, so in the desktop building applications, the Java is the most preferred language. Okay, so actually the C++ is the low level programming language. What by mean I low level is, it deals with the hardware, underlying hardware. It talks to the kernel of your laptop and gives you the output. So what is the disadvantage of this low level programming is you have to write a lot of code to perform a little or simple functions. Okay, so if you can, I can talk about this Python. The Python has different modules: C Python, uh, Python, and Jython. So by these modules, C Python, the Python is built on top of the C or C++, right? So what by means underlying, it is the C who talks to my hardware, and above over it, the Python who talks to me. You got my point, right?
Yes, sir.
So I write code in my Python, and underlying the Python code is converted to my C++, and then my hardware interactions are made. So this is how the C Python works on. And C Python as the same Python the which we generally use as a Python. So just like C Python, we have a different distributions of Python, which is Jython, where the Java is the underlying low-level programming language. So again, we have a Python, uh, and similar to that. Okay. So okay, cool. So we were talking about the development environment. So Linux, Mac, I recommend you the development can be done in the Windows, but it is a tough choice. But if you are you can make a choice, but I recommend you here go with the Linux or Mac. So Python 3.6 is the de facto environment. You need IDE for Python development, SQLDB or no SQLDB. So it is a database which you need for your development environment. And again, version control. By version control, I mean so Git, uh, GitHub or Bitbucket, whichever you like. You need this to in your development environment. And talking about the production enterprise environment. Okay, so these are the microservices. We will cover what microservices are in later. CI/CD again we will cover this in later. CID is a continuous integration and continuous development pipeline, which okay, I will tell you. So now you develop something. So let's say you develop print hello world and you want to show this to your teacher, to your something that but the teacher is remote and you can't ship your code just like that. Now the teacher asks you to, okay, hey dude, push this your code in some remote server. Okay, so if he or she asks you to actually develop some automatic mechanism that pushes your code as soon as you are done with the coding. So the current your go away is to develop go away with the CI/CD pipeline. So what it is the inbuilt robot which sits between you and your version control, and which is used to deploy in the server. Okay. So version control, why I mean, so if you push to some git push master, so some webhooks works in between, and that take your code from that master branch and deploys the same to your server. So the client or the teacher or whatever you want to anyone want to view your code, just go over to your server URL and see what you have actually developed. Okay, that's how CI/CD works. So Kubernetes OpenShift, it's again when your services are again very much you have deal with microservices. Okay, so you have the some you need something to manage that microservices where Kubernetes and OpenShift come into play. API gateway is again authentication gateway, and again after all you need and some underlying server to deploy your all code, which is the any cloud server, AWS, GCP, or anything. Okay, so hope you are all clear with your development and production environment. Hello.
Yes, sir.
Okay, cool. So actually, before diving into this, I would like to show you how actually the request flows. So here you are, user. So you request some web page on some typical server. So how request performs? It goes into the DNS probing. So the DNS probing, it looks into the which is the IP address of the website you requested. So that IP address now I assume refers to Route 53. Route 53 is the service of AWS. So that request goes to AWS and then tells that Route 53, hey dude, I found your address in the DNS probing. Now you have to route me to the actual server the client is requesting. Okay, Route 53 then tells you, okay dude, I will forward you to the actual servers. Then that request goes to load balancer. Load balancer is some of the guy that is sitting between your servers. So it decides whether your server 1 or server 2 should get the appropriate traffic. Okay, so then load balancer forwards your request to server 1 or server 2. Now assume that you have a multiple requests coming simultaneously. Okay, so again the same route is followed, and in that case load balancer assumes that server 1 is overcrowded, so it is getting some latency in responding to some requests. So it load balancer automatically decides where to route your request. Then it routes to server 2. Okay, here I would like you to assume that your same snippet of code is running on server 1 and same 2. I mean multiple copies of your code is running on both the servers. So here, now let's jump over to our example 1. So here, if you assume the scooter database we started with the updated in the server 1. Okay, so now again the same request 2 comes in, then the load balancer routed to the server 2. So here we have a scenario: the request got updated in the server 1 but not in the server 2. So then we end up with some problem. Okay, that's why I told you the client should always be as dumb as possible. So what actually the scenario is, server 1 and server 2 are connected to some one single database where they should read their all the data related queries. Okay, is that architecture clear?
Yes, sir.
Okay, cool. So everything in Python is an object. By the object, you mean you can assess their attributes, you can access their functions, anything by using some dot notations. Okay. So how Python code is executed? So Python code is actually currently executed by two ways. First is just go to your terminal, type in the Python, and you will end up with this three dot dot dot. So here if you can see, if you go to your terminal with Windows or Linux, whatever you are using, and type in Python, and you will see something. Just write the print hello world and you will see an output hello world like this. And the second way to execute your Python code is write some file, python test.py or whatever name you want to give, and then execute via in your terminal by python test.py. So these are the two ways how the Python code can be executed. So let's go over to the comments. Now you have like this, you can add some comments. This is a comment how you can add. You have something you want the reader should who is reading your code to be aware of. You can write that notation in this comment. So these comments are not processed by the compilers or interpreters, whatever. So you these comments are just for the readers that are reading your code. So you can write it in the two way, this way or like this. So same, the now the problem is how to store your variables. Now you have to access this hello two times in the in your code. Okay, so either you declare it here is the way how you can declare it. Okay, or you declare it two times or you use it by a variable. So these x or these are y are the two variables where you can put some assignments to your functions. Okay, so here you can see x equal to hello. Now I can use this x n number of times in my whole code wherever I need a reference to hello. So wherever I use the x, I will get that hello. So same is the case wherever I use the y, I will get 1.2. So here is the containers which can be used to store your values. Now the containers can be of many types in the Python. We have, I think, 5 types of containers in Python, which are where the containers can be integer, which can be a float, it can be a complex, sequence type, string, list, tuple, whatever. And we have a Boolean containers. We have a set. Let's actually, I think you will more understand it more clearly by jumping into the code, right? So let's jump into the code. Okay. So here, everyone can see my screen, right?
Yes, sir.
So,
Okay, cool. Let's execute our first function. Now we want,
Sir, can you zoom a little,
yeah,
sir? The codes are not clearly visible. Can you slightly
okay, yeah,
zoom?
sure. Okay. Yeah, is that okay?
Yes, sir. Now fine, sir.
Yes, sir.
Thank you.
Okay, cool. Now here I am in the terminal, my terminal. So I will tell you how the containers work. Here, if you can see x equal to 1, I will just type in my container x equal to 1 and it will assign the value 1 equal to x. Now whenever I use x, I will get 1. Okay. So now we have different types of the containers. If you want to check what the type of x, you just have to type x, and here you can see the type of the x is integer or int. So let's declare some another variable s equal to a, b, or c. Okay, this is a string. So again, we want to check the type of s. Just go ahead and check. The type of s is string. So what next? Our is float. Okay. So the float is nothing but some integer value with the decimal point. Okay. Now if you can see f equal to 1.1. Now we check the type of f. It is the float. Let's jump over to our next type, which is a complex. This type is rarely used, but for the knowledge purpose, you should know. But it can be asked somewhere, sometimes in the interviews or whatever. We usually ask in our interview process from our freshers how you define a float or complex types. So just like as I mentioned in the example, 1 plus 2j 2k or whatever, just go ahead and check the type of that. You can see complex types. Okay. So again, another container we usually the list is the most used container in our daily programming. So here how we define the list. So here you can see the list is actually a combination of multiple strings, I mean. So the elements of the list can be multiple strings. So okay, we can access the elements of the list by defining some index values of that list. Okay, so I will tell you by giving some example. Okay, so here b is my list. Now I want to access only the first element of my list. How can I do that? I just print in b and the list starts from 0. Okay, so from 0 I just telling the list, hey dude, return me the first element. So here can you see the a is returned in my programming, in my language. Okay, so same is the case with the tuple. So okay, so tuple is just as equal to as list. The difference between the list and the tuple is the immutable list. So if you define once a tuple, you can't really modify it. So if here, let's do that. Okay, so same, I think you can use that. Just like list, you can access the variables of the tuple, but the only difference between these are the mutables. That means once you declare that list, you can modify it as many times as you want. But this is not the case with the tuple. Your tuple you once defined, you have to stick with that, or else define a new tuple. So here how list works. And one thing I want to really tell you here is, if you want to access the last element of list, you need not to know every element. Okay, so let's say we have 100 elements of list and we don't really know the length of our list. So what we usually do, okay, this is the question I generally ask in the interviews. So what we usually do is just this -1. The -1 will give me the last element of the list I defined. Okay, so same, I actually encourage you all to play with the list as much as you can. But one thing I really want you to notice is the list is the container of same types. So if you are defining here strings, be sure that every element of the list is a string itself. So what I mean to say is this 1.1, like this float values or this integer value should not be it. The list should be the combination of homogeneous elements. The heterogeneous is not a case here. So let's jump over to the second part. Boolean. Boolean is again very important types in our Python programming. So it is generally used in the conditional statement, which I think we will cover later on. So if you want to set some variables as a true or something as false, you can use the Boolean type. So the set is again extension to dictionary, I think, which we will cover again later. So the only problem is not a problem, but it can be mutable. The problem I say this, it's unordered. So in the Python 3.5, the sets are unordered. So what I mean to say, the like in the list, you assume that the 0th element of the B is always A. Okay, here we assume when we type the 0th element is always A. But if we want the same functionality from the set, that is the 0th element is always A, that can't be possible. So the sets are unordered. So that means the B can irrespective of what you defined in a set, the order can be changed. So B can be uh, can come before element A. The B can be a 0th element, or B can be 4th element, whatever. So we have another last but and very more important type of container in Python is the dict. So let's say we have some mapping values. Okay, so we have a functionality like how many fathers are uh, there in some particular party. Okay, so let's say we have some fathers we want to calculate, and then we will give a, let's say, Ram and Sham, whatever values we want to give, and then we have to again calculate how many sons are there in a particular event or in a particular. Here we generally use dictionary values to store our value. So here A or B, like this, we use a dictionary. It is a key value pair which we use to assign the values. Okay, now you want to access all your stored fathers in a list. Okay, so here you just define that, and when you go over, just go over to, yeah, I want to access the fathers, and here you can get the result. Hey, you have two fathers in your particular event, Ram and Sham. Okay, so same is the case. You want to access the number of sons or whatever in particular event, you can access it by just using the key, that is sons. Here you will get similar values. Okay, I hope everyone is clear.
Yes, sir.
Yes, sir.
Okay, cool. So I actually want you to understand how list works internally. So internally, the list allocation is in the contiguous orders. So here I represented as a RAM. So this is a particular sectors of RAM, 1, 2, 3, 4, 5. So whenever you initialize a list, so the all the elements of the list are in the contiguous orders. So this is the okay. This is the first element, zeroth element. This is the first, second, third, and fourth, and so on. These are in the contiguous orders. So there these all actually you have to access it by the element 0 or 1 or whatever. So yeah, you can access it. The compiler knows if you are requesting the 0, it will go to the first element. Then if you are requesting some access to element 1, and it will again goes to you. He knows the element next to 0 will be the 1. Compiler knows because it is a contiguous, right? It is one after the other. So here how list works internally. So unlike other programming languages, in Python we can dynamically increase the RAM allocation. Okay, so okay, why what I actually really mean here is here you define some list s equal to 0 as some empty list. Okay, so the compiler automatically decides how much size to allocate this list. So in Java or in C++, you define ki whatever size you need. But in the Python, you don't really need to define the size. Compiler automatically decides on that. So let's say I want to assume you an example that compiler decides to give you a size of 5 to your list. So what it means, the five up to 5 elements the list can accommodate very well. But when you want to push the sixth element to your list, what the compiler does, it dynamically increases the size of that list to accommodate your sixth element. Okay, you got my point, right? It dynamically
Yes,
add
sir.
the yeah it dynamically add this sixth block, and not only sixth block but a sector of other blocks to allocate the increased size. So this dynamically allocation is where the compiler takes some time to dynamically allocate that sector of RAM to your variable. So that's where Python took time, and that's why Python is termed as a bit slow or a bit whatever. So okay. So again, in the list, the iterations are in the sequential order. So if you want to access some particular value, you have to go by a 0, by 1, by a 2, by a 3. You have to go in the sequential order, which actually results in the complexity, space and time complexity as order of n. So elements are called as items. So this 0 is the one item, this 1 is the another item. So all these elements of the list are called as items. Again, as I showed you in the live demo, the items can be accessed by A0 if you want something that is stored in this sector, A0 if you want something stored in this sector, A1, and the last element can be accessed by A minus 1. Okay, so similar to that, how dictionary works, dictionary actually indexes your keys. So how many of you knows how hashing works actually? Gives me some indication. Otherwise, I will cover the hashing. No? Okay. So I want you to assume hashing is nothing but some magical method which takes input and gives a unique output every time. By the unique, I mean to say for some function, I give a as the input, and as an output, that function always returns me a 2 or 23. Okay, so whenever or whatever the condition is, whenever I give my hash function an input of a, it will return an always 23 value to me. Okay, so hope you get the idea. So here in the dictionary is Python, how the things work internally. If I want to set up some dictionary or some, like here we go with some dictionaries. Here is the key that is to be hashable. By hashable, I mean to say this is the value that goes to my index method, and then index method returns me the corresponding memory address or where the memory is available and where this key should be stored. Okay, now what it means, every time I gives father to this hashing function, it will always returns me this memory address in this format 1 2 3 4 5. Okay, so that's the base function how dictionary works. So that's what makes the dictionary a little bit fast as compared to list, because it's all based on hashing method and all the keys are indexed. So again, the dictionary will throw the key error if not present. By the key error, I mean to say, now if we defined f earlier. So if we want to access something that we haven't defined in the dictionary, so we are accessing mother. We haven't defined in the dictionary. Here you can see the my compiler will error. Hey dude, your mother is not defined in the dictionary that you defined earlier. So better either you define it or either you don't use it. Okay. So in the production scenario, that's why we use a get method. So if the things are not defined, we want our compiler should not throw an error. That's the main motive of using the get method. So here, if I tried the same thing using the get method, the compiler will return none. So none is not really very visible in that particular scenario, but it will not throw a key error and my application will not crash at all. Okay, so that's why the get is used. So hope everyone is got my point, what the how hashing works. Yeah.
Yes, sir.
Okay, cool. So anybody has any questions?
Sir, what's the possibility of getting a crash, sir, if the code is in error?
The code is in error. What is the possible? I can't get your question. Can you repeat, please?
Like if there are lots of errors, so how is the possible getting crash, sir, the code?
Look, the compiler is exactly telling me what's the error. You have to read the error, right? So here you see the compiler is telling me, hey dude, you have a key error. Why key error occurs? Because I requested compiler something that doesn't exist at all. Okay, you have to go through the errors to understand what actually the error is. So either way, the compiler is not that much error friendly. If you can see, not on every iteration compiler doesn't throw an error. If compiler throwing error, it has to be some reason, and the reason is always defined in the error traceback. Here you can see. Okay.
Yes, sir. And does the compiler randomly choose the size of the empty list?
Yeah, it is inbuilt function of the compiler. You can't control what the size you have to give. It is controlled inbuilt.
Okay.
Okay. So cool. So here, by using the hashing key, we make sure the order of n the order which is the O n in the first case, in the case of list, the in the case of dictionary, the order blow comes down to O key power 1. So here you can see on the first iteration itself, you are giving hashing method some input ABC, and it is directly giving you the address of that value. So we came up again end up with the order O key power 1 because we need not to iterate all the methods, all the elements of our dict that are present, we can go to the point. That means if I am accessing mother or if I'm accessing father, I can directly jump over to father. I need not to iterate over the sons. I need not to iterate over any other unnecessary variables, which is not the case in the case of list. Okay, which boils down to our time and space complexity to not space but a time complexity to order of 1. Okay, should we jump over next? Any questions up to this point?
No, sir.
Okay, cool. So now there is a case loops. Okay, for that I will define a simple loop a b c. Let's define it something like that. Oh, okay. Sheet. Okay, I define my list something like that. Okay, so the thing is, how can I access my each variable in this list is just go over to my loop and give the index value that I want to access. So index value will give me Sheetal, index value 1 will give me Reena or something like that. Now, in the actual case, in the real scenario, it is really not possible if the list is beyond 100, or let's say the length of the list is beyond 1000 elements or whatever. So the we can't really give this 0, 1, 1, 2, 3, 4, 1000 values. So here to our rescue, the loops come into play. So in Python, we have two loops, for loop. So here if you can for m in my loop. So here you can iterate over one element at each time and do your computation or print something like that. So I will print my element here. Let's see it in a compiler. So here you see my loop is going over to my the list that is defined each time. Firstly, it is going to Sheetal and then Reena and then Seema one by one. So here how for loop works. So on the similar ground, we have a while loop in Python, which works in the on the same way. So in the while loop, we have one disadvantage over for loop is we have to maintain the index value. Okay, so if we want to go over the next element, we have to update the index of the next element by our own. So if you are familiar with C or C++, I think you will get my point. Okay, so this is how loops work in Python. We have a few statements. Okay, like continue, break, range. So before going into this statement, we have some conditional checks in my loop. Okay, so let's say I define my list as my loop this. So I want the when the cursor comes to the element named Sheetal, it breaks down. Okay, so for that thing, I will give my compiler some condition. So condition like in the similar C++ or C case, we have if else condition in Python again. So I will give if m equal to Sheetal, I want hey Sheetal. Okay, so like here you can see when the m comes out equal to Sheetal, it prints out hey Sheetal. But in the other cases, when the m is equal to Reena or m equal to Seema, the no action is taken. So here how conditional checks generally works in the loops or in whatever in your programming language, wherever you are looking for your conditional checks, you want conditional checks, you can put it like this way. So yeah, jumping over to continue break. So okay, we have the same loop in my loop. I want when the cursor comes to whatever it is, what Sheetal, just continue to the next iteration. Just ignore Sheetal at all. We don't want to deal with Sheetal at all. Okay. In the other case, when the cursor is something else other than, we just want to print whatever the value is there. So let's execute it. Here you can see the Sheetal is not printed. Reena and Seema is printed. So here continue, when the cursor comes to Sheetal, it will continue to the next iteration. In the next iteration, Seema or Reena comes up and it prints out the similar case. Got it? So yeah, okay. So same is the case, a little different with the break statement. So here in the break statement, I want when the cursor comes to Sheetal. Okay. Okay, I got some invalid syntax. Just break that loop at all. I don't want to go to the next iteration. Okay. So here I think we have some problem. I'm in my loop. Okay. Let's execute in this file itself. I told you in the initially. Okay. So let's execute this. How to execute this in the file? As I told, we have to jump over to our terminal, and you can okay. Yeah, here you can see on the first iteration itself, the Sheetal is coming. So the my loop is breaking on the first iteration itself. So the nothing is coming up to the print statement at all. So if we change our program to something like Seema, it will come in the first, second, third iteration. So ideally, our cursor should print Sheetal and Reena. Okay, let's check it out. Yeah, it is. So our cursor prints out the Sheetal and Reena respectively. So you got my point, right? What the break and continue statements used for?
Yes, sir.
Okay, cool.
Yes, sir.
So now coming over to the range, now you have a use case to define something range up to 1000 numbers. So I think you are unlikely to build a list that one by one and putting or pushing some values into that particular function. So what usually we will do is we we put some for range, and we give the end value of our iterations, what we want our list to be. So range is nothing, it is an inbuilt function in the Python which gives our list up to that element. Okay, so here I can go over to each element one by one, and I will break it if things are above 10. Okay, I can comment my code right away. Just put some hash in front of each of the elements, and the compiler will not execute my code at all. So let's execute this thing, python test.py. Here you should see the numbers like this. Okay, I this thing never worked because it is equal to, I put string equal to. Actually, it's an integer, so this condition never got resulted to true. That's why the loop doesn't enter in this way. So let's execute again. Here you can see my code is printed up to 9 only, and I'm breaking on the 10th number. Yeah, got my point?
Yes, sir.
Cool. So next thing we have in our Python is the classes. The classes is first class objects in the Python. By the first class, it means it can be equated to some variables like we did in the list or we did in the dict. Yeah, the writing of classes should be in the camel case. It should be, yeah, class is a reserved keyword. It should not be used as some variables. So like this, my class, my pet equal to this. So that's how class works. So similar is the case with the functions in Python. Function is again the first class objects. The name should be of lowercase every time. Unlike classes, the names and the camel case is followed in the classes in Python. So the lowercase is followed in the functions in the Python. So we have 4 types of arguments in functions. Okay, I will cover this by one. The first is the required argument, keyword argument, default, and let's cover this. Before that, functions definition always starts with the def. As you can see, actually, I put that in the first. Uh, yeah, here I defined the some function. All my definitions of the function where I want to define my function, it always starts with the def. So yeah, and another thing we have in Python is the anonymous functions. Anonymous functions are like functions of this kind. Uh, it is the shortest, and if we have a single line of operations that we have to perform in our code, we generally use anonymous functions. We don't really need to define the whole this big of syntax each time to define our functions. Okay. So coming over to the types of arguments, we have 4 types of arguments. Let's cover each of that. We have a required arguments. So here you see, if you want to execute my function, the X is always required. So in this case, when I'm giving trying to execute my function without X, the compiler will throw me an error. Hey dude, you have X as the required element and you are calling my function without X. That's not acceptable at all. Okay, the compiler will throw in an error. So next is the keyword arguments. So if we have a different type of arguments like x or y, and we have to define only one value in that, if we want something like that, so we can do that by using this keyword argument functionality of Python. We can do that by x equal to 5, or y equal to 5, or x equal to 10, or whatever. This functionality is called as keyword argument. And the next we have a default argument. So then here is the use case. If we generally not concerned about defining x each time. Okay, so we give a default value. Hey dude, if this function is called, hey, and it is coming without argument, so the number 2 is automatically picked up because I set it as a default argument. So my default argument, this thing will return 2 into 2 as 4 in this case. So when I execute this function, my default argument 5, then this 2 will override to 5. So when I execute this, it will come to 5 multiplied by 2 equal to 10. So we can also use the keyword argument here, my default argument. Here the number get overridden to 6. So 6 multiplied by 2 equal to 12. So in the third scenario, we comes out as a result as the 12. Okay. So fourth and last is the variable length argument. So there is the case here you are defining some list having values 1, 2, or 3, whatever. But you are really not sure what is the list of arguments you have, what is the really length of the arguments you have. So in that case, we generally use args and quarks for keyword arguments, args for the arguments. Here you can actually put some different number of arguments. Let's say 1 or 2 or 3 is again acceptable. And if your input is 1 or 2, it is again okay. The compiler will not throw an error at all. So in the function itself, we just iterate over to each of the elements and do our computation. Okay. So last but not the least, we have anonymous functions. I think it is for the single line of computations generally used. We generally use. Okay, is that okay? Any questions up to that point? Hello.
No, sir. No, sir.
No, sir.
Okay, cool. So we have a different types of programming styles we generally follow in the Python. We have a functional programming and we have a class-based programming. So functional programming, we have a pure function. By pure function, I mean to say whenever my argument is same, my result of that function should be same. So talking about this particular function, this default argument, whenever my argument is 2, my result will always be 4. This is an example of pure functions. So it should not be case that I am putting 2 each time and I'm actually referencing some variable from outside and somebody modifies that variable in the second iteration. And when I reaches the second iteration, the answer comes out to be 10 or whatever. Then that function should not be called as a pure. The pure function is at X number of times you iterate, I will give you the same result. So this is the currently paradigm we follow in the pure function programming. So recursion is generally used in the Fibonacci series. So I think I have example. Yeah, here Fibonacci series recursion is the calling the same function n number of times. So you actually compute the result of a particular by looping over by using the for loops or while loops, whatever, or by calling the same function with the different arguments each time. Here, if you can want to find the Fibonacci series of, let's say, 10, so either way, you have to either loop over that over one by one, or just call that function with a different argument. In the first case, let's say I will come up with a 10. In the second case, I am minus with the 1. The second argument will be the 9, and here the 8. So the stack will go on increasing, and at the end, in the recursion, whenever I defining this recursion, I have to ensure my exit conditions should always be there. So by exit conditions, I want to have some base conditions which I want my loop to end whenever my n is equal to or less than 1. I want my this call stack should end. If I don't define this exit condition, my program will end into an infinite loop. Okay, so here if we mock it, so first is the 10, then the second is the 9 and 8. So third is the 8 and I think 7 goes on, goes this thing goes on, and we go into negative infinity, up to negative infinity, and my compiler will hang at all. So by defining this exit conditions, I am just telling my compiler, hey dude, whenever you reached number 1, just return 1. No more recursions to be followed after that. So this is the type of structures we generally follow in the functional programming. Functions are the first class objects, and that functions can be assigned to some variables, and these variables can be passed as an argument here. Here it can be some functions. Here, let's say I defined a function equal to multiply x. Okay, so in the next function, I am just passing this multiply as a variable. Okay, so here you can see whenever I call get number will pass this multiply, which is actually a function, to this my return, and then I will just call this function here and execute that thing. So in the end, when the function has a suffix as the parenthesis, this parenthesis means I want to execute this particular function. Whenever I'm referencing this particular variable without parenthesis, it's just a simple variable. So I'm executing this in the get number, and I am multiplying this x with the 2. Okay, so here if I send this 2 to this, get number will get 2. It will go over what is the multiply, then it will get the definition of multiply from this. So here I will execute the multiply. Multiply is actually x multiplied by 2. X is equal to 2, and which is 2 into 2. My result will get 4. Fine. This is how first class objects. So function variables are immutable. So in the functional program, if you are define something, let's say x equal to 1 or whatever it is immutable at the end of your programming. It should not be like you are defining x equal to 1 and x equal to 1.1 at the other time. This is not actually acceptable practice in our daily programming. So whenever you define something, it should be equal to that thing for till end. And the good thing you can do is you can define y is equal to something new variable, whatever you need. So referential transparency, by referential transparency, again, this is related to some state of the variable. That means once the state is of variable is defined, the state has to be kept till the end. So yeah, that's all about functional. Like talking about the class, in the most scenarios we don't really need class. So you will need class when you have to maintain the state of some particular function, you have some behavior to maintain, and you have some identity. Okay, so I will take the example of here. Here, I define a class name of the car. In that particular class, I have three states to maintain. So I have to maintain what is the company of that car, what is the color of that car, and what is the model of that car. So based on these state attributes, I can calculate the behavior. Okay, so from the model and from the company, I put some my computations that 2012 model of this Maruti runs on this maximum speed. I can calculate, right? So from in the similar way, 2012 model of this this Ferrari runs on this mileage. From based on these state variables, I can define my behavior. So here, if you have to maintain the state of your particular thing, you will define the class. And coming over to how class defined, so here it is. If you need to ever define the class, you just call this class, and the name of the class name is nothing but the identity of your class, and that defines the behavior of your class. Now you have to want to define some speed like this. So here you can put some formulas to calculate the speed of your particular car or whatever. So that brings to our next thing, that is the class constructor. And what class constructor is, it is the very first variable that is defined whenever we call this class. Okay, so actually I will tell you by just using. Okay, so now if you can see, I will not I will call the class only. So here, okay, I will call the class only, and you can see the constructor is automatically called. So similar is the case with the C++ and everything. Whenever you define the class, your constructor is the very first function that is called along with their class. Okay, so similar to this constructor, this is a double underscore constructor, or we all in Python we also call as the dunder methods or magic methods. Okay, similar to this constructor or double underscore methods, we have another magic methods in our class, which is destructor, the REPR, which works on the inspecting class. If we want to inspect whatever the class variable is, the length of it gives the length of some particular instance of my class. A doc string of a variable. Okay, so what I mean to say doc string is, I defined something as a doc string in my class. This is doc. Now whenever I initialize my class a equal to abc, and I call my function as doc. Okay, so I think so. Yeah, here you can see I can access whatever the doc string I gave here by just giving this magic method dot doc. By putting this, it returns me this is the doc variable, right away. So the doc string definition is very much important. It defines what your class actually does, what this class actually builds on, what is the purpose of this class, because you write your code today. So in the later year or after 2 years, somebody reads your code, he or she should get an idea what this class is actually written on the first time. Okay. So that's why the doc strings are put into place. So printing instance variables uh, is a str used, and we, if we want to put some, use the name of my class in my, then underscore underscore name. And there are other magic methods which are defined as soon as you initialize your class. I think you will get to know more about later. So similar to other things, we have error handling in the Python. We have a try except block. Okay, so let's error handle this thing. Okay, I will define my method something. I will define my method something like that, print k. So here you can see k is not defined at all anywhere in my class. Now whenever I try to execute this method, ideal case it should give me some error. Let's do this. So here you can see my method takes 0 positional argument, but 1 is given. So I can't show this to the user, to the client actually. So in ideal case, what I will do, I will use some error handling techniques of the Python here. So I will push this code into my try, into my except block. Now again, if I try to execute this, a is not defined. Okay, here it is. Okay, here it is. Now the exception is handled gracefully. Okay, here you execute something, but my method is executed, but here the k is used. So k is not defined. So you put this into the try except method, and instead of giving the compiler output to the user or to the application client, you handle it gracefully by wrapping this thing to your try except block. Okay, so this is generally instead of print, we generally use the log statements. Here we want to log to our server logs, and then we iterate over that log, so whatever our server hit in the first place. So finally is that statement that goes along with this try except. So this is a statement which get executed either your exception in the method, this method in your try except hit exception or not. In the either case, the finally will get executed. So that's how finally is used. And raise is the something you want to raise some error. So I want to something in the first place. Let's see here, my method pushes some exception. I handled that exception gracefully. I logged it. I put some logs in that, and then I want client to know there is some exception. So instead of writing you can use inbuilt exceptions also. We have inbuilt not found exception, and whatever, we have a range of inbuilt exceptions that you can raise, and the user of your applications get aware of that the exception is raised. So the general question here actually I receive is why you don't really forward that exception that is generated on the first place by the client itself. The reason is we can't really log that case. We have to log it to actually eradicate that exception. If there is exception on our end, there is some errors on our code, we have to log it. So then we log it and then we raise that exception accordingly to our best convenience to notify the client that you guys have an exception. Got it? We have a built-in exception, arithmetic, assertion error, attribute error, OS error, key error, and many more. We can raise it according to our convenience. Any questions up to this point? Hello?
No, sir.
Okay, so do anyone want some break or something? Or if I can continue?
We can continue, sir.
Hello?
We can
You can go
continue.
ahead, sir.
Okay, cool. Now that comes to the types of inheritance we have in the Python. We have a single level of inheritance. I defined a class grandparents, and it is inherited by a class parent. So we have multiple inheritance that I defined some class A, class B, and the attributes of same class get inherited to my class C. Then we have multi-level inheritance in the Python. So here is the typical example of grandparent, parent, and son. The son here C will contain the characters of parents and your grandparents also. And then last but not the least, we have a hierarchical inheritance. Here I define some class. This type of inheritance is generally used to define the structure of your class. Same some abstract methods of your class. So we generally use it by defining some structures. Or say, let's say we are designing some car, and all our cars and the deriving methods of our car should have four wheels, should have window panes, should have smoke pipe at all. So here, whichever our functions are common in B, C, D, we define in this particular case. So all this does is we define some abstract class here. This B will inherit the functions of our abstract class, and if we want to do any modifications, B can modify the functions. If not, then it's okay. Similar is the case with the C. C can modify or represent anything accordingly. So here, if you can see Maruti Suzuki 800, or let's say example of Swift Desire, and these are the cars all inherit the four wheels methods. But the thing is, they define some additional method in them to suit the functionality of the user, which is the case particular here. Here hierarchical inheritance is used. Okay, so that's all about inheritance. And coming over to the framework library, now you wrote some code. Okay, so that's the code that you wrote, some the something like that, this test2.py. This is called as the module. So I can ship this module to anyone that is sitting, not really collaborating with me, to any external user. Hey dude, use my module to get the specifications of your code, of your car, or whatever I defined. Okay, so then multiple modules combine together to form a package. So I put this multiple modules. I define something programs about car. I define something about similar of about truck, how truck should look like, and I define something how train should look like. Okay, and I then package them to a single folder, and I then ship that to something that to external user. So I call that thing to as a package. Just note that package always has init.py file in the particular folder that you are shipping to the third party. So which makes that a package. So again, multiple packages combined to make a library. A library is I think a core Python module which we ship really. Like each package can have a multiple libraries or whatever. So same is the case with framework is some different kind of structures where multiple libraries can be used to make some framework. So firstly, we need to understand why framework is really required. So giving you an example, we are defining some web applications, like say some I want API designs, something I want my server, if I want some parameters hit like this, and I want my server to give me the details of all the users the currently that are in the database. So in the ideal case scenario, I have to process the request that is coming to my server. I have to make sure the request doesn't contain some elements that can bring down my server, some hack attacks. I need to prevent some hacking attacks. Okay, I need a clean request. I need some exceptions to be handled gracefully in my server if there is. Uh, like similar case, I have multiple functionalities that I need to be taken care of, and to write these functionalities each time, it is not really feasible to write the functionalities from the start, from the scratch itself. So that's when the framework comes into place. The framework is a kind of set of libraries that are inbuilt into a single structure that we install the framework. Let's say Django, we install that. So the Django has a inbuilt login module in that. We really need not to worry about writing our logins, our authentications, worry about how the request is authenticated. And we just have to use the single function, pass in the parameters in that function, and we are done with that login module. So similar to that, a framework can have a multiple libraries. So that's how a framework really works. It gives us some boilerplate code. We need not to write everything and anything from the scratch itself. So package manager is something a cross-platform. Package manager is something I think you all use your mobile phones and everything, right? So in your mobile phones, you have Play Store. So Play Store is nothing but a package manager. So what it does, it distributes some apps to your mobiles or to whatever. So same is the case with the Python. Python has a Play Store as a pip. Preferred installer package is widely used package management system. Okay. On the similar ground, we have a pip env, which really works as compared to npm in the Node ecosystem. Conda, we have a similar to that Conda, which is maintained by Anaconda team. And this Conda package manager is generally used in the data science structures. So that's how package manager really works. So all you have to do is just pip install some particular module. So here, okay, here you wrote some module, here you wrote some package. Somebody else wrote your package. So the ideal case scenario is it push that package to some central repository where you guys all can download that package and use in your project. Okay, so that's to connect you to that central repositories. We use simple pip or ppnv, whatever. So pip Python maintains that central repository and gives us access to download libraries that are written by millions of other developers like us, and use it in the free of cost or like or paid whatever in our project as per our requirement. So pip, PM, PNV, Conda, whatever these guys are used to connect us to and download that package library from that. So yeah, we have a standard libraries. Standard libraries are the libraries that comes built in the Python. So okay, I will give you an example. So here, if I want to use date time from date time, I this is a standard library. I really need not to install this library to use that. This comes as the standard, and the from date what I'm doing here is I'm just importing that library into my code. I'm telling the compiler, hey dude, I want to import this library. I want to use this library, import it. So here, that's how I can import. So from date time import dt, and I can always rename the import from date time as dt as dt. So now what it means is, and each time I want to use this library, I can just reference it by dt dot the time or whatever. This thing I want a current time, I can use this way like that. So that's how importing packages. The import structure is same. The third, either it's a standard library or it's a third-party library which I installed via pip or Python and whatever. I use the same import like this. So that comes. I actually want you to just go over this quiz, and this quiz has some questions that we cover just, and it gives me understanding how well you guys grasp the topic. Just go over it. I will wait over, I think, 10 minutes, and we will meet again later. Is that okay? Hello?
Yes, sir. But the
Oh,
link of
Can you
the
put
quiz,
put that link in chat box so everyone will be accessible for them.
yeah. Can you access that link?
yes, sir.
Cool.
Yes, sir.
Yes, sir.
Cool. So, okay, everyone is done. Okay, should we wait or go ahead?
We will continue, sir.
Okay. So actually, the results of the quiz are not very much motivating to me, really. So if I
Sir,
can see,
actually, yes, sir. Actually, everyone, most of them are beginners and they have from
I,
last
un-
week we have started.
no, I totally understand. So the for after the quiz, anyone has any questions, just ask me out. Actually, I dropped the idea of going over to the framework discussion because firstly we should be very much comfortable with writing code in the Python language before jumping over to the framework. Okay. So based on the quiz or based on the discussions we have up till now, you guys have any questions, just ask it out.
Sir,
Yes, yes.
sir, could you tell about the .pvc file?
Yeah, sure. Okay. For that, I will bring you. Just give me a minute. So can you see this? This is a folder, typical folder of my project. So whenever I initialize my any of my project, any of my file, Python file, when I try to execute that, the compiler makes the binary code of that version. So next time when the file got executed again, compiler need not to process the same file again and again. So it makes the binary code and saves it in the dot underscore underscore PyCache folder. So here you can see on the all the files that my project has .py extension, the binary code of the same file in .pyc extension is maintained in this folder. Okay, so here I can give, I have a url.py file. So I go into the particular folder, I can see url.cpython38.pyc. It is the same file that is generated by my compiler as a bytecode. So as I think you guys understood that our machines understand only the bytecode. So it doesn't understand the high level programming we actually write. So the compiler each time has to compile this high level programming into the bytecode. To get over the same thing again and again, compiler saves this conversion and makes that pyc file and saves it to my PyCache folder. So now I can delete this PyCache folder right away. So the next time again when the compiler comes to my want to execute this my current file .urls.py, it again converts it to .pyc format and saves it to this respective folder. Okay, it actually used that if there is no change in URL PYs, then there is a no really sense of converting the same file again to bytecode again and again. So compiler saves that iterations that the conversion of the PY to PY bytecode again and again and saves the converted code into the PYC. You got my idea, right?
Okay, sir. Thank you.
Yeah. So any other questions you guys have, please ask it out. So what I will do is I will push you guys. I have actually planned to go over to GitHub a simple CRUD operation tutorial, but I think it is not the right time. So and one